Hello and welcome to the section 5.2 lecture. Sorry that I didn't start at the top. We'll go ahead and do that right now. Today we're going to talk about writing linear equations from a table. So the main thing about writing equations from a table is tables give you points. We just went over section 5.1d. That was all about finding an equation given 2 points. So I'll bet there's a whole lot of carryover in this section to that last one. So let's just jump right in and take a look at it. The first one talks about a table, shows the temperature of a fish tank during an experiment. We want to graph the data, find the slope and the y-intercept, and they're saying from the graph and then write the equation in slope-intercept form. So it's almost like taking a step back, but it's what I talked about in class, that we can always just graph our equations, graph whatever information we're given, and see if we can figure out what we need to from that graph. So they graph all their points. They're putting all their points on the graph. They draw a line. That's the line that we want to find the equation of. We want to figure out what equation models that line. Because eventually we're going to want to say, okay, well, what happens in this one of temperature over time? What happens at 20 hours? Well, my graph isn't that big. I don't want to draw that line that far. I don't have a long enough ruler. Whatever the excuse may be, there's times that it's more beneficial to have the equation. So then they choose 2 points. They choose 0.82 and 180, and they find the slope. And they find the slope to be -2, which means it goes down 2 degrees every hour. And it's always important to kind of think about, all right, I found that slope. What does that mean, right? What does that mean as like a unit rate? Because that's really what it is. And then they use the slope and they find the y-intercept. They just found the y-intercept from the graph or from this point right here, okay, the 0.82. That gives us this point right here, meaning that the y-intercept is 82. Not too bad. And they write the equation, y equals -2x plus 82. Let's go ahead and look at what they have for us next. So they've got a table for us, and they also give us a graph. So I'll bet we're going to graph it and then find the equation. Now, we learned over the last couple of days that we don't necessarily have to do that. We could do it just from the points that they give us. In fact, they give us some pretty big looking points. And it might almost be easier to just use the 2 point idea. But let's go ahead and play the game a little bit, see what they have for us. So it's important to notice that all these give us points, right? I could put parentheses and separate them with commas. That's the big thing out of tables. And understanding which one is your x and which one is your y, which one can fluctuate, and then which one depends on that fluctuation. Right, so the volume of water is definitely dependent on the amount of time in this situation. Okay, so at 5 seconds, we have 75,000, which is going to be right about here. At 10 minutes, we have 150,000, so that's this nice little grid point here. At 15 minutes, it's 225, so that's going to be another kind of ugly point. We're just kind of guessing about where halfway is there. And then 20 at 300,000. And so we can get a line going. I'm going to pick on 2 of the grid points that I know and make sure that it goes through those 2. Okay, so my line looks about like that. So I might guess that my y-intercept is 0. And then backtracking a little bit, we do need to find our slope. And I'm going to use, I say backtracking because I kind of covered those points up, but I want to use this point here and this point here. And I want to find my slope on the graph. I'm actually not going to use 2 points. I have the graph. They told me to use the graph. I'm going to use it. Okay. So it looks like here that it goes up 1, 2, 3, and over 2. But we have to ask ourselves, what does up 3 lines mean? Well, each line is like 50,000. So it goes up 50, 100, 150,000. 1, 2, 3. Okay, and then it goes over And this one's a little bit easier to see. It goes over 5 seconds, 10 seconds. So over 10. Okay. And so we can write that slope as 150,000 over 10. Okay, now what does that mean? Or what does that reduce to? Well, since we're dividing by 10, that's like just getting rid of a zero. Okay, just getting rid of a zero. So we have 15,000. 15,000. And again, what does that mean? That means 15,000 cubic meters of water, right? 15,000 cubic meters of water for every second. That's actually pretty quick, but I mean, come on, it doesn't really matter. And then I think we can go with that guess of the y-intercept being 0. That's a pretty safe bet. So we get the equation y equals 15,000 x plus 0. I don't have to write that plus 0. But again, I could have done this problem just given the 2 points. The only kind of iffy part there is that the numbers get kind of big, right? These numbers are very large. So it's not that it makes it any harder or any easier. It's just a little bit more to keep track of. Like if I were to find my slope using the 2 points, I would say x1, y1, and x2, y2. And then I'd be going 150,000 minus 75,000 over 10 minus 5. 5. And so that equals, again, this is finding my slope. So that's going to be 75,000 when I subtract, divided by 5, which actually ends up as 15,000. Okay, so 15,000 is my slope, and I could plug in any of those points. If I plug in that first point, just because the numbers are the smallest, so we have 15,000. I feel like I'm going to run out of room. Plus b, we think that we should find our b to be 0. But let's double check that. So if I plug in y as 75,000 equals 15,000 times 5 plus my b that I'm just going to skinny in there. Okay, that's a b on the edge. Sorry about that. And it turns out that 15,000 times 5 is 75,000. So I have 75,000 equals 75,000 plus some number. Well, either using just general knowledge, 75,000 plus what equals 75,000, that's going to tell me b is equal to 0. I would get the same thing if I subtracted 75,000 from both sides. I would get that b equals 0, giving me this equation. Okay. Let's go ahead and look at this next one. It says that Elizabeth's cell phone plan lets her choose how many minutes are included each month. That's kind of nice. She can choose every month. Maybe not. The table shows the plan's monthly cost y for a given number of included minutes x. And we want to write this equation. So they go ahead and looking at that table, notice that it just gives us a bunch of points. So we can pick any two and go through that same process. So they find the slope, and they find out that it's 0.06. Now, what does that mean? Okay, I know that this question isn't really asking us that, but what does that mean? The y's were the cost, right? This means 6 is the cost over 100 minutes, okay? Which reduces down to 0.06, or 6 cents per minute is basically what it comes down to, okay? And then we find the y-intercept from the table. So again, they write in what they know, the 0.06 for the slope, And then they plug in just the first point. They have 14 as y, 100 as x, and they're going to solve for their b. They subtract 6 from both sides, and they get that b is 8. And then this is the big thing. This is the thing that my students are struggling with. Take what you know, put it into the equation. Okay, that is your answer. Because that's something that you can tell everybody, and they automatically know what they can do from there. Okay, now, I should say, I guess, you might have to say, if you're just going to give them this, they might kind of look at you like, the confused dog look. But if you said that y was the cost, so y equals the cost and x equals the number of minutes, they would have a better idea about what they could do with that. Okay. Let's go ahead and see what these problems have for us. So what is the base price for the cell phone plan, regardless of how many minutes are included, and what is the cost per minute? We just kind of said those. Well, some of them. We know that the cost per minute is 6 cents. That's what we said. Oop. Should probably put a dollar sign in there anyway, so we're just going to erase that. We have 0.06, 6 cents per minute. Now, if she bought 0 minutes, if she had 0 minutes on the plan, okay, that would be like plugging in 0 for x, which is actually going to give us our y-intercept of 8. Okay, so again, I'm kind of recalling this without going back. The base price means 0 minutes is $8. So if she just gets the phone, maybe she just wants it as a Wi-Fi device. She just wants to use it as an internet device, always connected to Wi-Fi. There's no minutes to be bought, no data, no messages. $8. What if Elizabeth's cell phone company changes the cost of her plan to this one shown here? They just found a quick little way to make this a lot more work, didn't they? Yeah, they did. So we need to find a new equation by finding the slope and finding the y-intercept. So let's go ahead and do that. We're going to use these first 2 points. This will be my x1, y1. Oops, sorry, that's my y1. This will be my x2, y2. And I'm going to start up here because I know that I'm going to take a lot of space for this. Y2 minus y1, so we have 35 minus 30. X2 minus x1, 200 minus 100. 35 minus 30 is 5. 200 minus 100 is 100. So that's 0.05. So we have y equals 0.05x plus b. Let's move over here to find our y-intercept. I'm going to use this first point in this equation. So my y is 30. 100, not 100 yet. How about 0.05 times 100 plus b. 0.05 times 100 is 5. So we have 5 plus b. Subtract 5 from both sides. I wish your book showed this step. It would help out a lot. 30 minus 5 is 25, so my y-intercept this time is 25. Okay, and so we move that to 0.05x. My pen is lagging out a little bit, plus 25. It's a pretty drastic change, right? It really is. I mean, not only the fact that my y value at 10 or at 100 minutes is 30, whereas it was 14 before. So, it's like $16 more expensive just for the 100-minute plan. It also changes in a lot of different ways. Yes, the cost per minute is cheaper. It's a cent cheaper, but whoop-de-doo at, at getting a cell phone plan. But the base price is now $25 instead of $8. So the base price is a lot more expensive. Okay, let's do another one. I guess two more. It says a salesperson receives a weekly salary plus a commission for each computer sold. So the table shows the total pay Y and or the total pay P. So that we're treating this as our Y values. And the number of computers sold N, we're treating those as our X values. Write the equation in slope-intercept form that models the situation. Okie dokie. So let's go x1, y1, x2, y2. And you could really pick any of these as your ones and twos. I picked the first two because typically they're the smaller ones. Okay. So y2 minus y1 for my slope. y2 is 700, y1 is 550. 700 minus 550 over x2, 6, minus x1, 4. So we have 150 when we subtract those, and when we subtract these, we have 2. And when we divide that, we get 75. So the slope is 75. 75x plus b. And plug in any point you like. I'm going to stick with the first one just because the numbers are the smallest. I have 550 equals 75 times 4 plus b. 75 times 4 is 300. So I have 550 equals 300 plus b. If I subtract 300 from both sides, over here they cancel out. Over here it gives me 250. So what that means in terms of the problem is their base salary is $250 and their commission for each computer is $75. So we get y equals 75x plus 250. Now to really write this the way they want it, with the letters that they want, the total pay is equal to 75 times the number of computers plus 250. Okay, I get very stuck with y and x. I apologize, but you know, what can you do? Let's see, next one. It says to rent a van, a moving company charges $40 plus 50 cents per mile. The table shows the total cost C and the number of miles driven D. Write an equation in slope-intercept form to represent this situation. You could go through and you could find all the same things that we did already. But you could also read the problem and find it yourself. Since they charge $40 as a base price, that's my Y-intercept. Okay, that's my B. And with a slope, to find the slope, it's the amount that it changes per mile. Well, I'm actually not going to fall into that trap again. I'm going to call number of miles D for number of miles driven, and they charge us 50 cents. And that's going to give me the total cost. So I kind of worked that one backwards, but you could have done it just as easily in the straightforward direction. Okay, point 50 times the number of miles plus the base price of $40. And that'll be it for today. I thought there was another page, but I was wrong. Hopefully that helps out. I think today we need a code word. I'm going to go based on the problems that we've seen. We're going to go with tables. Everything today is about tables. So that will be our code word for the day. So make sure you write that somewhere. Don't forget it and get it right. Have a good day, and we will see you in class.